Hello. This talk is called Designing HTTP Interfaces in RESTful Web Services. My name is David, and I have a weird way of spelling my name with actual two dots. And those are not an accident. Because I'm from Germany, from Munich more precisely. I just fled Oktoberfest. But I had enough beer. So it's not really a loss at the moment. Where I work as the founder of a company called Bitextender. We do web development, consulting, architecture, scalability things. Lead developer of the Agave framework, which is loosely related to Symfony. And this is my Twitter nickname in case the Wi-Fi works for you and you'd like to praise or bash this presentation as I progress. By looking at the olden days before the term REST was even well known to the world. And we had URLs like this, right? Anybody remember those? Yeah? Who still has those? Ooh, brave. See? Kudos to you for admitting. And so everything just worked fine, right? Like it's okay. And then these SEO experts showed up. Experts as in like they just make up stuff about Google. And they said, "Nein, you can't have URLs like this." At least the Germans. So we had to have SEO-friendly URLs. And the SEO-friendly URLs looked like this initially. And because, then after a while, people just started getting more creative, especially with the advent of Ruby on Rails, where you just have slashes for everything, because they all didn't have a clue, right? And we got from the latest hamburgers to the Zomquolcats page 1 ordering by 2, I don't know. And so that was a problem. And at the same time, roughly around the same time, a bit before maybe, everybody was like, oh, we need to have service-oriented architectures, right? And that was usually SOAP, at least in the earlier part of the 21st, whatever, decade, the last one. And here we have a get product request. Please imagine a laser beam on your side. We have a get product call here. These lasers are great, right? I'm sorry, I don't have two. I should be wielding like two shark-shaped lasers. So get product, and we pass an ID 1, 2, 3, 4, 5, 6. And this is because SOAP has a standard way of conveying the method that's to be called. This is classic RPC. We call a remote procedure called get product on the remote, right? And we pass it one argument, the ID, and the fact that the ID is an integer is documented in some sort of WSDL file, which is machine readable. So it translates that from the XML back to some sort of object or whatever call on the server side and does everything. And the response is going to be probably a product with an ID, a name, and a price. And again, that's specified in some sort of schema embedded in a WSDL file. And then client and server can do the marshalling from objects to this XML format over the wire and back. And if the product doesn't exist because 987654 is not a valid product, it's going to return a standardized fault, again, inside the standardized SOAP envelope that you see. And it uses an HTTP 500 internal server error. But other than that, it does not use any of HTTP's status codes to convey that the product doesn't exist, right? Because in HTTP, you could say it's a 404 because the product is not there. But because SOAP was designed to be transport agnostic, they can't do that. It's just, it doesn't care what the underlying transport is. Amazon, for instance, until, just a couple of years ago, when you visited a product page on Amazon, they would make around 15 to 20 calls to a SOAP middleware, but not via HTTP because that's too slow with the handshakes and connection setup, etc. And also not XML because that's just a few bytes too many over the wire. So they had custom serialization, and they had just direct socket transport, but the principle was the same. They call a get product review count method on the server, etc. And they do a bunch of these from the front end to a middleware. Boom. And who's used SOAP? Hands up if you didn't hate it. There you go. So part of that is because especially like in the Java world, this whole interoperability idea was just a complete mess to the point where you could not, from an Apache Axis 1 client, could not make a call to an Apache Axis 2 server implementation and stuff like this, even though it was supposed to be interoperable. The other part is that many people either didn't write WSDL files for their servers, or as client users did not understand that a WSDL file, because theoretically a client for this is just new SOAP client, passing it the WSDL file, then you call the get product method, and that's it. You don't have to do you don't have to generate the XML, etc. But most people did that. They generated the XML by hand, and nothing ever worked. So people started hating it. And when the people hate it, they say, oh, that sucks. And then they quickly say, let's build something better. So I'm sure you've all heard of joined in, because all of today's talks and tomorrow's talks are going to be on joined in, and you can give feedback to the speakers. And one of these examples is the old joined in API that looked like this. I think it's still online. And so you make a request and you pass authentication information without using HTTP's authentication mechanisms, right? I'm sorry, you guys are not getting enough laser features. And then you call get detail, right? And you pass a talk ID. And that's basically the same thing as SOAP, just with different tag names, right? So you get some sort of response back. And it's actually worse because it uses its own way of authenticating a user. And we also always make a post request to a specific endpoint. So even though we're just fetching information about a talk, we can't use a GET request because we need to pass this XML chunk that handles authentication and tells the server what operation we're trying to invoke. So that is a problem because always a post is not good. You can't cache anything. You can't use HTTP authentication in this case. And in order to understand what type of operation we're even trying to call, any intermediary, like a proxy or a load balancer, needs to understand the message format in the body. And it needs to understand that get detail might be something where we just fetch information and then it can cache something. So you can't take a varnish or a squid and put it just in front of the service and have stuff cached, because it's a post request and it doesn't understand anything. It's just, whoa, it's a post request, pass it along, right? That's not good. And so nothing is cacheable. And also everything goes through one endpoint. So from the perspective of any intermediary, you're always just hitting API talks, even though you could have one endpoint per talk ID maybe, right? And there's a guy called Leonard Richardson. I met him 2 weeks ago, just by chance at a conference. He's a funny person. And he, at some point, had a conversation with Martin Fowler. You guys know Martin Fowler? Some of you? Yes, he's written a bunch of books. Some of them are good, some of them not. And then Fowler wrote a blog post about Richardson's maturity model, where basically he goes from level 0 to 1 to 3, 2 to 3. So it's 4 levels, 0 indexed, describing how nice a RESTful web service is. And 0 is not RESTful at all. And it's even from an HTTP perspective really crappy because it just sends XML over the wire and doesn't use any of HTTP's features, right? And you could now improve this by giving every endpoint, like every talk, its own endpoint. So instead of going to API talks, you go to API talks 42. That's not much better. That actually makes things more complicated in that specific case. So that would be level 1. And the only things that you need to know about level 0 and level 1 is that they're a bag of hurt and you shouldn't use them ever. I'm serious, like no, not ever, ever. But then there was salvation, right? Because Roy Fielding rocks up and says, here's this REST thing. And that was really, really great because everybody could say, I have a REST API now, when in fact they didn't. because there's one aspect of REST in particular that we'll discuss today that's frequently overlooked and that people don't understand. And the first clue is in the name. And I would imagine that many of you have heard this term a lot, representational state transfer, but not thought about it, what it actually means. Representational state transfer means that we use representations to transfer state of resources. across a network. This paper, Architectural Styles in the Design of Network-Based Software Architectures, is not about HTTP. It's about building distributed applications over a network and what the requirements and implications of this are, right? And in there, he basically defines a list of constraints. Most of them are fairly easy to understand. One is it must be a client-server architecture, which to us, being web developers, is really straightforward, right? We have a browser making a call to a web server, for instance. These requests should be stateless, so there is no protocol-level mechanism to allow a server to identify that any request is a subsequent request of another one. We hack around this limitation in practice in our web applications by using cookies for session IDs, right? But on a fundamental level, the protocol doesn't require this. In browsers, we just need it because there's no logout buttons for HTTP authentication and a few other things. These requests should be cacheable. Don't have to be, but should be. And that is mostly a consequence of the requirement that it should be a layered system, which means that you can have any number of intermediaries between client and server, and those are completely transparent to the communicating parties. So a client, the web browser, does not have to know that on his way to google.com, he goes through a squid proxy on the company's network, out on the internet, into a load balancer on Google's end, and then to their application service, right? The code on demand constraint is optional. We can ignore it for today. It's basically you ship code to the client to enhance the experience, which is basically JavaScript. But for the purpose of this presentation, it doesn't really matter because you've all heard of JavaScript, and it doesn't apply so much to machine interactions. And then the last one is the uniform interface. And the uniform interface is the one we'll want to focus on today. Because the uniform interface itself, again, has a list of requirements. And these are, in no particular order, that first we have a URL to identify a resource. And then we use a method called like get or post or delete to perform an operation on this resource. And this operation should not be part of the URL. So you don't have /get detail or something. We have /edit and stuff like this to show edit forms because, content negotiation and web browsers, so that's special cases because we can't put, etc., yada, yada, yada. But if you think a robot makes a call to another robot, he doesn't need a /edit endpoint. He just takes something and puts it to a location identified by a resource. And when he does that, he uses a media type. If you want it to be RESTful, it must be a hypermedia type. We'll look at what that means, but I'll give away already that a hypermedia type is a media type with defined semantics. And then the client can use link relations in the responses from the server to navigate through the system. And those last two bits might be the constraints that you are not so familiar with. And before we look at the implementational details of this, here's one thing that goes back to the representational state transfer thing, where we transfer state of resources through representations. A web page, if you look at it in a browser, is not a resource. It is merely a representation of that resource. Because when you make a request to get a list of products, for instance, and you say, I accept application JSON, you get back a list of products, right, but as JSON. Now, the same resource, the list of products, could also be in XML. So those are two different representations for the same resource. And in both cases, we have just one product, the red stapler for €3.14. Neither application XML nor application JSON are hypermedia types. All application JSON says it's a bunch of curly and square brackets with defined rules on how to parse it, and if you leave an extra comma somewhere, everything breaks. And XML is it's a soup of angle brackets, and most people hate it for the wrong reasons, and it's slower to parse. But there's also, we'll look at hypermedia later, right? But there's also HTML. HTML is actually a hypermedia type, even though it's a bit of a special one because most of the meanings it defines for its tags just talk about generic document structures and instruct a browser to render it appropriately for human consumption. So you can use HTML to have machines communicate, but it's a bit cumbersome. And in case of HTML, we get back an HTML document with a list of products, right? And again, here we have a link to a product. And earlier in the XML, for instance, we also had a link to the product. In this case, I used Xlink. So we have this concept of representations and resources and everything. But first of all, we want to move representations across the wire to do something with the resources. And to do that, we need an HTTP interface. Before we can be RESTful at all, we should use HTTP. We don't have to use HTTP for REST. REST is not coupled to HTTP. It just happens to be that HTTP semantics map very well to most of REST requirements, right? So it's a very good application. And nobody has really bothered to make a better protocol than HTTP. Speedy doesn't count. It's just handshake stuff and SSL. So it's pretty much the same thing. Which is good, by the way, because like there's some idiots who want like a stateful something, and that was called Gopher and failed in the early 90s. So all this statelessness thing and like, oh, I need to do long polling because that's good. It's not bad, even though people complain about it, because that's how the internet works, why the internet works, but we'll look at that in a moment. So if we design an HTTP interface, what I like to do first is I define my resources by giving some structure to URLs, because then as a human, I can understand it more readily. And you might have seen a bunch of these, like /product and then something behind it. It's usually people who have their entire collection of holiday photos in a folder called photo for some reason. And we filter by, not sure categories or actual cats in descending order, I guess. So as we add more slashes, because there's more filtering options, because every day somebody comes up with a new idea for sorting, filtering, or doing something else, you'll have more slashes and more slashes. And ultimately, you have so many slashes that certain parts of the URL can't be optional anymore because you have ambiguity in these parameters, right? So that's something to keep in mind. And then you address an individual product and possibly the photos of the product, even though that order makes no sense at all. And then you can have a new. I don't actually know. It's either a new photo or a new product, and this. It's not quite clear to me whether the first one is a photo ID or a product ID. So that's bad structure. So we want good structure. We have a list of products. And then if you want to fetch the list of products in a specific way, for instance, by reversing the order or by filtering, we should use the query string, because that's what it's for. I know the Ruby on Rails folks don't like it. But you can add more arguments, and none of your clients have to know how many slashes to add and what piece goes in what part in the slash. And you can use any standard mechanism like HTTP build query to construct the URL. So that's good. Later on, if you have a really elaborate service, your server, when I just fetched a list of products, could at the end of the list of products embed a form or some sort of instruction set, maybe a list of fields, ideally just an XHTML form, right, with a bunch of fields and an action. And then each client could just look at the action and look at the number of fields. I understand the filter field and the sort field. And it would know, because it's defined in the XHTML standard, how to turn a form when I click submit in a get method into this query string. Done. No effort in documenting like how to construct the URL, etc. We can address an individual product, and as a subordinate resource, more slashes mean belongs to. That's actually something that the HTTP spec mentioned somewhere. We have a list of photos, right, which we can, again, use a query string on to sort and then address an individual photo. Now, we've done this, and we have a nice structure for our URLs. And then I turn up and say, you know what? That really doesn't matter. Because once you're properly RESTful and use hypermedia, and hypermedia as the engine of application state, which we'll get to in a moment, it doesn't matter at all what your URLs look like. It just could be SHA-1 hashes, right, for everything. But it's helpful to do this anyway, because it gets you as a developer into this whole mindset of, I need to actually think about how to lay out the things I want to represent in my system in a meaningful and structured way. And that's good, because then ultimately your API is going to be cleaner. And also, people who look at URLs more immediately understand what a list of photos is or something. OK, so now we've done that. The next part is we use these resources, right? So we have a collection of products. We use get to retrieve it. We post to it to create a new product, which is defined in this way in the HTTP specification. It says you post to some location and create a new thing inside that location. You can also use post to call a script and blah, blah, blah. I mean, generic things that are basically, backdoors for cheating on the specification. But this is the basic. And what does that return? No. For a web browser, yes. Because web browsers, we want to redirect them to the location, right, to the new resource. It should return a 201 create status code, which is HTTP's way of saying, I created a new resource as a consequence of this request. You could also return a 202 accepted, which means, OK, I'll deal with this later, but haven't done it yet. And along with the 201 created, you send a location header, right? Because many people send a 200 OK, and then a bit of JSON that has status colon OK, ID colon 55. So I know that something happened, and then there is an ID number 55. So now how do I get to, what did I make? A product. How do I fetch product number 55? Do I append the 55 to the /product/ thing? That's stupid, right? Because if you ever want to change this, or if I want to program against another server that uses the same protocol, my code needs to remember, oh, I called that API or that other API. Not good. So the location header has the full URL, and I just follow that URL. I don't have to do any URI construction at all. And then if I have fetched such an item, I can, again, by using a get, I can also put to it to update it and delete to delete it, right? When I do a put, I send the complete representation. I don't just send the description field. If I put just a description field, then the product is going to consist of just a description. That makes a lot of sense, because this way you get optimistic locking, which is what HTTP does. You can say, I want to put the whole thing with this price and this name and this description, right, to this location. And then you can optionally use these conditional headers like if match and send an e tag along that you retrieved earlier. And that basically tells the server, update this resource, but only if the version that the client has is the one you also still have. And then the server can compare and say, well, the product has been updated since in my database, since in between the client fetching it, updating it, and trying to push it back. And then he can reject the update. He can say, precondition failed. You should fetch it again. See if your update still makes sense, because maybe what you put in the description doesn't make any sense anymore, and retry, right? If you want the description to be updatable individually, you could either use patch, but that's a bit of a pain, because then that's a separate media format for your media format, so I'd like to patch on it. Or you just say products 12345 / description. You make a virtual sub-resource, right, that contains just a description, maybe even as text, and then people can put that to just update the description. So that's a convenient way out of this dilemma that you don't want to send 5 megabytes of information about a product over the wire. So we've done that. And now I've written such a thing, but hopefully you've remembered that you should not have this client have to maintain any sort of state by sending cookies along or something. That's for browsers, right? Machines shouldn't have to do that. I don't want to send a cookie that says this is my session ID or something. It should be somehow obvious from the location. Maybe you have, if you want to have a machine managing 100 shopping carts at once, each shopping cart should have its own URI or something, and then you can put items in and check them out individually. Because on a web browser, it's not a problem, right? We're logged into Amazon, we have /checkout or /cart, and that's our shopping cart because I'm just one person using one browser to do one checkout process. But machines might not want to do that. So remember this. And once we've done this, we've reached level 2 in Richardson's maturity model. So we use HTTP verbs, get, which is safe, which means it has no bad side effects on the server other than maybe logging. And it's idempotent, which means I can repeat it as many times as I want, and it's still going to be the same result, namely fetching the thing. If I post, that's not safe, because that changes the database on the server, right? And it's also not idempotent, because if I post the same product 5 times, I'll have the same product in the database 5 times, unless the server employs some sort of mechanism for detecting that it's a duplicate. Put and delete, however, while unsafe, because they delete something or they update something, are idempotent, which means that I can repeat the same put with the same update information 100 times. It's still going to be the same updated information. I can delete something 100 times. It's still going to be gone. Right? And we use HTTP status codes to indicate result success. For instance, we say 409 conflict, the price you've entered is not appropriate for the category you've sent along, because $7 is really too cheap for a car. Now, anybody use the Twitter API? Because the Twitter API is a really good example. Is anybody from Twitter here? That's a really good example of how to do it wrong. So we're not even looking at the RESTfulness. Like, I don't think they've ever heard of hypermedia, et cetera, et cetera. It's just like from an HTTP perspective, it's really bad. Because currently, they do these things. So, for instance, you have to say, show me 1, 2, 3, 4, 5 .json. And you can't send an accept header saying, I want JSON. You must add it to the end of the URL. It's always good to have this optionally, so I can say .json or .xml quickly in a browser when curling something. It's just a little bit more convenient to debug as a developer. But not allowing HTTP's standard mechanism for content negotiation is a bit questionable at best. Then we can destroy the thing. So we send a delete to the destroy status. Then we have separate collections for the retweets. So we fetch the retweets, but we set just a new retweet. So logically, it will make a lot more sense to use the same collection for this. And then also I can put to create a new retweet, which is a bit strange, because that's not what the HTTP spec says happens, right? You want to post to create a new thing. But there's something particularly wrong about the update endpoint. So first of all, what does update do? Guesses, please. Updates, what does that mean?
Post a new tweet?
Yeah, it posts a new tweet. That's really shitty terminology, if you pardon my French. Hello, Frenchies. Yeah. So, but there's something else. Something else is wrong. So besides, it should be create.json. It should be create and not JSON. But anyway, there's something missing there. What is it? First person who tells me gets as many helicopters as they can carry at a time. Yep. What user am I posting a new status for? That's pretty essential information. They fetch it from the authorization information, from the auth header, right? But what if they ever want a feature where 10 people with their Twitter accounts can all tweet on behalf of another account? Would be really good for company support, right? Like any company they have their own Twitter channels for customer support. And it would be really useful if they just said, well, we have 10 customer service agents just for Twitter, so we delegate access to them for our account. They can't do that. They need a completely new endpoint that they need to maintain and document separately. Not good. And it could be so much easier because you could just have, like with any username, a list of statuses. You post to it to create a new tweet. And any individual tweet you could delete, maybe even put to update in the future. So within 10 seconds of tweeting, you can still change it. After that, it's permanent. And then you have a list of retweets that you can fetch or post to create a new one. And they could send back, instead of like IDs, they could send back URLs, and you follow them, and everything would be really easy. It would be a lot easier also to work with as a client, right? And that brings us to this little question I have for you. What's the biggest reason for the success of the web? Because it's really, I mean, there was email before, right? And people sent emails. But the World Wide Web, that's the first data exchange system that we have that works and operates fully on a planetary scale. Planetary scale means it spans a planet. That's what our planet looks like, in case you didn't know. I think that was taken by Apollo 17, the blue marble photo, the original. But so how did the World Wide Web end up being so large? How is that possible? Well, it's the hyperlink, because the hyperlink doesn't have any tight coupling. Imagine we wanted to exchange information in this room, and I would send I would send emails to roughly. Oh, yeah, cool. Do I have to cut anybody in half? No. Well, you guys are. Well, no, it's fine. Don't worry. It's just an arm, just a flesh wound. So I send an email to this half, right, and say, here's something really important. And then you guys, you have to walk over and say, hey, what's your email address? So I'll send you my email address, and then maybe you can reply. That doesn't work well, right? That doesn't scale. With a hyperlink, well, I just post this hyperlink somewhere, and you just all follow it because things point to each other. And that means it's loosely coupled by design. There is, for instance, if I wanted to link to somebody, and that person maybe links back or not, there is no notification infrastructure to tell the other person that I've linked to them. There is no requirement for me to tell everybody who's linking to my page that I'll be deleting my page soon and they should please remove the links so I can remove my content, right? There's just that 404. It embraces failure because everything else would be completely ridiculous. I couldn't link to google.com without calling them and like, hey, Google, can you link to my web? It's like the link exchanges of the late 90s. That wouldn't work. It embraces failure by design. And the consequence of this design is that we can add more information to the system without increasing the friction on a technical level, right? I mean, we now have the problem that we need to find all the information. And back in the day, we used the manually maintained Yahoo catalog of pages that were mostly GeoCities and funny GIF animations. But we need a search engine, but that's a different topic, right? We have no limits to scalability. Because back in the early 90s at CERN, Tim Berners-Lee and the others were smart enough to make a protocol-centric thing that didn't care about, because they were egghead scientists and they like references and sources and attributions and stuff. So they could have said, well, anything I link to must link back so I have consistency in my scientific library thing that I'm building, right? And the HTML link to this day has a rel attribute, which you might be familiar with. So I can say a link to something, and that is related to me in this way. And you can say a rev, the inverse relation. Right? So I can link to my father, and the inverse relation would be I am the son. But it doesn't require the opposing party to link back to me. And that was a smart decision, as it turns out, because all of a sudden we have this thing where we can, well, basically buy everything and do everything and consume everything, movies and whatnot, and communicate. And one of the reasons why that works is because we as humans do things slightly differently, which brings us to RESTful services with hypermedia. So the uniform interface, we've already learned, requires identification of resources, right, through URLs. And remember that the representations are conceptually separate, right? So we have a JSON and an XML of the same resource. And we manipulate these representations, these resources through their representations. So we send the whole XML along to update it, and then ideally the JSON reflects the update as well. These messages are self-descriptive, so the server and the client have everything in the message they need to understand and parse it. Other than obviously documentation that's somewhere that told the developer how to handle the code, but we don't have to fetch out-of-band information like a whistle file or something to understand things. And lastly, we should be using hypermedia as the engine of application state with this really unfriendly German abbreviation of HATEOAS. Somebody just had a shitty day making that up. They go, weather is bad, I'm going to call it hate something. So, and that's the important ingredients for the REST, for the whole REST awesome thing. Because that's what we're still missing. So if we have a SOAP web service, right? We'll have a create product method maybe that we can invoke on the other end, and we have a get product. But nothing tells us that we have to call create product first, and then with the ID that's returned, pass that to get product to fetch the product. You'll have to document that somewhere, and it's going to be like you need to call initialize before you can call execute and everything like this. So in an HTTP interface, we want to do this better, right? But how do we tell our clients what the next possible operation is? Like we want to go to the next page in a search result or something like this. How do we create a new resource? Where is this whole contract thing? And it turns out that with this HATEOAS thing, it's actually contained inside the representations because we use links, and the clients can use these links to discover new locations and new operations, right? And they do that by programming or being programmed against well-known link relations that express the concept of this is the next thing, or this is the category of the product. And one of the big advantages is that the clients don't need to know the URLs or their structure in advance, so they can change. And you can also, if two servers both implement the same media type, clients can theoretically run against both of them by just knowing the entry locations to the service, and then everything else is just discovered by following a bunch of links. And that, to a certain extent anyway, abstracts the whole application workflow that could then even change, possibly, depending on how dynamic and how creative and clever the client is. You can version this media type to introduce breaking changes. And ultimately, what you'll end up with is many clients that don't break just because you add a new field or because you say, well, there's now different new ways of doing new things, right? I've already mentioned that XHTML is such a hypermedia format. Others would be Atom or OData. You could also build your own, like a very basic custom one to represent our product would be if we fetch a list of products. So I fetch 1, 2, 3, 4, and I say I accept application/vendor dot. So that's a prefix where you can just make up your own media types. You don't have to call the IANA and fill out a bunch of forms, and then they discuss on the mailing list whether they would like to accept your media type. So you just say, I don't care. So we say application/vnd dots, and then maybe some Java package syntax or so just to avoid name collisions, plus XML. You've seen this before with application/xhtml plus XML, which is a standard notation for saying this is basically our domain-specific thing, but it's based on the rules to handle application XML, which means the underlying parsing rules of application XML, etc., still apply. So if we wanted to have our own media type based on JSON, we would say application/yada yada yada plus JSON, right? And then clients know, okay, it's based on application JSON, so I can parse it as JSON, and then interpret it with rules specific to that problem domain. And the response is this product. I was lazy and just reused whatever Atom has already documented for the link relations. And we have a link here with a rel payment that's defined in the link relations list. I'll link to the link relations list later in a later slide. You can download the slides later, by the way, so you don't have to write down URLs. And I'm also actually being just a nice HTTP server. This has nothing to do with REST, or not much. And I'm indicating to the server that he may use other methods on the same endpoint as well, for instance, to delete a specific product. I've also put it into an XML namespace just to blah future-proofness, but it doesn't really matter much. And once we've done that, we have level 3, right? Because from this, any client could go to the payment operation, for instance, which is difficult on its own because how do you do the payment? But just ignore that problem for a moment. And we have level 3, right? And I used XML because it's really good for hypermedia formats, at least for formats where you don't control all the clients. If you have control over all the clients, or if you just write a service for your own JavaScript frontend, please use JSON, right? But if you have 100 applications and you're trying to ship an update to them, well, you might be in for a bad surprise because with XML you have like hyperlinks, namespacing, etc. JSON also doesn't. JSON has a completely different document model. If you have this document, if we started with these two, right, and you see the JSON here and the XML, and in the JSON I've already made an array of objects because I anticipated there being more than one link, right, at some point. But here we have a product. It costs something, and in the JSON I already anticipated having a bunch of links, but there's a price, right? And now, boom, I want to change that to have a currency attribute. And with the currency attribute in XML, the node value, the content of that element doesn't change. So any client who's written to fetch the price element and read the value, because it knows that's the price, doesn't break when I update it this way. There never was a currency attribute, so it never cared about a currency, so it doesn't have to know, right? It's just extra information that I, at some point, decide to send along. But I had a price as a float earlier in my JSON service. I can't change that to an object containing a currency attribute, because all the clients are written in such a way that they expect a float there, not an object. Boom, stuff breaks, and you get a call at 4 in the morning from someone who's like, oh, my really important iPhone app is broken because your API is stupid. What? I'm sorry. I wasn't meaning to offend anyone. I'm just German and honest and analytical, and that's, yeah, we are not very charming people, I know. I'm sorry. I apologize for everything we've ever done wrong. So, well, okay, that was a bit much, but yeah, jokes about the war. Okay, so JSON is really difficult because it doesn't have the same document model as XML. As I said, if you control clients and servers, then please use JSON. If you don't have if you don't have control over it, if your business model from the get-go is going to be, I want as many people interacting with this service as possible because I'm building some sort of platform that others should use, then do yourself the favor and at least offer an XML version and tell people the JSON version might break, so if they use it, they're out of luck. But with the XML, you actually can make it work in such a way, because XML has this nice document model where if you represent a product like bacon, I hope no vegans in the room, then you can, first of all, it allows mixed content, right? Which is mostly just useful for HTML and other formats where you can just have text that, tells people how much you like bacon. But you can add just a currency attribute to any price, as we've seen earlier, and it doesn't break any client because they just fetch the value of the price element, and if there's an attribute, they don't care. And you can add a second price element, and that's also really important, without breaking anything, because any client who wants the price element needs to write either some stupid DOM query with get elements by tag name or something that's really complicated and you shouldn't do that, or a very simple XPath where you say within product, give me price and the first occurrence, right? And then if there's a second or a third, nothing breaks. Obviously, the server always needs to send the original old, maybe default currency or something first, so existing implementations don't break, right? You're laughing. But you can do that, and then you can say, well, in addition to the English bacon, we also sell German Speck now, and it'll just work. And you can introduce new elements that the clients never knew about. You can probably also do that with JSON unless people marshal it directly to something in the database, and then boom, there's a link and they don't know what to do with it and stuff blows up. And then we're back in, soap land, the things we've tried to escape and avoid. So keep that in mind. And also another thing, please, if you don't use hypermedia, not this defined, documented semantics of a price means this and a product means that, and et cetera, then you don't have a RESTful interface. But you don't actually have to feel bad about this. Maybe you don't want that because you say it's too much effort and it's just my internal stuff and I don't ever have to communicate with anybody else. So I can construct URLs from IDs that this 201 created thing returns. Or maybe you're building something that can't be RESTful, like CouchDB. Anyone ever used CouchDB? Or S3, right? S3 doesn't care if you store a text file or a video. It doesn't understand the contents of the video or what the text file says. It just stores something. So that can't have associated meaning with your problem domain. It's just storage. That can't be RESTful. Just don't call it a REST API and then I'll be happy. The LoveFilm API. So LoveFilm is like Netflix. It's not a porn service. It's Netflix. Okay, and no, because you guys don't have. You just have Netflix, I think. So, and that's a really good example for something that's hypermedia driven. Because here I've searched for old, as you can tell from the self link. The self link is in the search, so it means whatever I'm enclosed in this case, a search, is me. So you send a client the information about what page are we currently on. So maybe you delegate the code somewhere else, and then you don't have to keep track of the current URL because this gives you the current location. And we looked for old, and we want one item per page. And there seems to be a bunch of pages, but you can also see the next and the last link. So I can follow the next link, and then the next link, and the next link, until there is no more next link. So if I want to spider their whole product, in this case I think computer game catalog, I can do that. My client is a while loop following the next link until there is no more next link. Right? And here you also see an interesting thing. For next, they used the rel next, because that is defined in this IANA link relations list. So it has a defined meaning. It means in a sequence of things, it goes to the next thing. But for something like reviews for Knights of the Old Republic, that's really domain specific. You can't have a generic reviews relation that applies to the whole world, right? So they've made their own. In this case, they used a URL, so they would not collide with somebody else's reviews, right? Avoid naming collisions by using a URL, similar to what many people do with XML namespaces. And here, they are linking to a location on their server. Now, one thing that's actually missing here is the type attribute that tells you what media type is on the other side behind that link. Because you could link to reviews twice. Once as HTML, once as machine readable, for instance, right? And then the iPhone app could pull the reviews to quickly maybe compute a summary of the average score. And it could also have a button to open on my iPhone the reviews in Safari. But there is a much more important thing. These guys got bought by Amazon a few years ago. They could decide tomorrow that instead of linking to something on their own service, they link to some endpoint on Amazon's service that still produces the same good old love film media type, but fetches reviews for the products from their database. And no client would even know. They just pull some stuff from a URL and done, works. That's cool, right? That's interoperability. There is still room for improvement here. It uses application XML instead of a defined media type. So if they do that, and if Netflix does the same thing, and I run some sort of, I run some sort of service that tells people what's cool in the world, and I want to link to the item for rental on Love Film and on Netflix, they're both application XML. But they're different types, right? Because they've just different engineering teams each made up their own media type. So how does my client know that one is Love Film, and how do I interpret these? That's why application XML by itself makes no sense. I just know to parse it as XML, but I don't know how to interpret the contents, right? So once they did that, they should have a type on each link telling me what the type is. And ideally, they should use XML namespaces because it's just a lot easier for a client to just look at the root element. Is it the namespace I understand? Is it the tag name I expect? Yup, continue parsing. It's actually another thing you can't do with JSON, right? In JSON, you would have maybe an underscore type field in the JSON representation. So a client knows, it's a list of search results, it's an individual catalog item or something like this. But you need to download and parse the whole response for this. Whereas in XML, you can do streaming parsing, which on mobile clients can actually be an advantage. Another good example is the Huddle API. It looks really similar. And so one thing you saw earlier here is they have an ID to the catalog title. This really should not be ID, but link rel equals self, right? Because the self now refers to the catalog title element that it's contained in. And Huddle does that. So Huddle has two actor elements inlined in the document representation here, and each has a link to itself. And the document itself also has a self, right? But they've invented their own relations like avatar, etc., and they did not use a unique URL to avoid name collisions with somebody else's avatar. So they should do that instead. And they use one global XML schema and one global namespace for everything, which makes clients a little bit more difficult to write. One thing I would like to demonstrate, like just with a quick example, is how powerful the API versioning can be, because that might give you like a good idea of why it might be a very, very good idea to build a RESTful web service with the hypermedia thing. A lot of sites have something like blah/v1 and then blah/v2. There's even REST books that recommend this. But first of all, the problem is those are technically different resources, right? So any proxy compare, like looking at the URL, etc., things, those are different. So you can't send a simple purge request to your varnish, etc., without a regex in the v1, v2. And the other problem is that maybe machines would like to bookmark something as well. Maybe a machine would like to remember a product URL in its database because it downloaded the information and associated whatever it has in its database with the URL, and then just a few minutes later it can fetch it again to synchronize. And let's assume that happens and we fetch an individual product this way, right? We get a product back, and then some time passes before we want to fetch it again. And during that time, the item sells out. It's gone. And now, if we fetch it again, we get a 404. Because we never had any concept of availability in our system, so we want to prevent the clients from selling this thing that's not in stock. So we say 404 not found, and it doesn't do anything with it. But in the meantime, or maybe before or after, the server could have offered a new version of the interface that knows what availability is, right? And then, if we say we want version 2 of this interface, we would get a new representation that has a new field, availability, right? Version 2 documents what availability means. We can't just add availability retroactively to an existing media type documentation, because there's clients out there that were never written against this. We can add a description field or maybe category links for existing clients. They can just ignore it. They don't need to know that there is a description. They can ignore category links because they've been doing fine by just selling things without categories, so that continues to work. But if you all of a sudden add an availability field and expect clients to not sell something if availability is false, well, you'll be in for bad surprises, because there's guaranteed to be some clients that didn't get your email about, hey, there's going to be the breaking change like tomorrow at 4 a.m. Pacific time, where we add this field and you now have to interpret it and you need to set deadlines, etc. It doesn't work. So instead, you have a new version of the media type, problem solved. So remember this. If you use URL-based versioning and not version through the media type, then clients can also never upgrade the protocol. They also can't remember the URL and later on say, well, I want version 2 now, etc. And another thing to keep in mind is, what if PHPBB or Drupal or something had an API, right? So the PHPBB guys come up with a very nice URL, with a very nice API with a media type for a forum software. And, they shouldn't have like version numbers in there, because URLs for forums tend to be vastly different. You can have the sharksforum.org, and then the API v1 is a bit later in the thing, or it's at the very beginning. So I, as a client, need to start regexing the URL for /API/v1 to make sure it's version 1. So that would be bad. And also, what if the PHP guys did such a good job that a bunch of other folks, like vBulletin, says that's such a good API, we're going to support that, because there's 500 iOS applications and Android applications to browse forums. We just want to be compatible with this. They then also have to have API v1 in their URLs, and that's not good for interoperability, right? So, as we're 10 minutes over time, you might be wondering why this is also awesome. Because we talked about the merits of REST, and it's easy to evolve. It's actually, for us humans, easy to learn, because we can look at a representation. We see a bunch of links, like to link rel category. And then we look at the documentation again that says the category relation means this and this, and then I go, okay, so I follow that link, etc. So I click my way, maybe with a browser extension or something that shows me XML or JSON nicely. I just click through the service to learn it. All all the server needs to do is it needs to document what elements in my JSON or XML mean what, and what the possible link relations are and their meanings. It doesn't have to say a product URL looks like this and this. So that's good. And as we add things and as we add new link relations, as we add new elements, it scales really well, right? I don't have the problem that I need to maintain 100 versions, at least not hopefully. And then there's the other aspect that it's really easy to implement because it builds on top of HTTP. That means we get all the kick-ass things for free, like authentication, transport layer security, content negotiation. I can just add a varnish. I can just add a squid. Done. Right? So now you've seen these two sides, and you might be asking, wait, if HTTP gets me all these cacheability, et cetera benefits, then why would I bother with the REST part? There must be something other than just the extensibility feature that I need to sell to my boss that doesn't fit well with agile development methodologies. And the answer is no. As his Royness Fielding, the guy who invented the term after all, said, it's software design on the scale of decades. And lots of the constraints are directly opposed to short-term efficiency. And because people are bad at long-term design. And another aspect, of course, is most developers simply don't care what happens with their API. Chances are that the APIs you write, by the time you need to extend them in such a way, as we've discussed, when it would be a problem for clients, you've already changed jobs, right? So why would you care? So keep that in mind. If your business model from the beginning is interop with other parties that you have no control over, the hypermedia thing will save you a lot of pain, or your successors a lot of pain. If you're interested in all this, there's some further reading. How I Explained REST to My Wife is mostly the uniform interface, etc. It's a funny conversation. Ryan Tomiyako now works at GitHub, I think, and helped design some of the APIs. How to Get a Cup of Coffee models the Starbucks ordering flow as a RESTful web service. And then the Fielding's dissertation. I recommend reading that like maybe for breakfast or like with a cup of coffee, because I always fell asleep when I tried to read it like in the evening. And there's a bunch of books. The cookbook. In the cookbook, Subu will tell you that you should version through the URL. Ignore him; he's wrong. I've told him; he doesn't agree. And so Leonard Richardson. Well, we just had a fight, and then we agreed to this. Like, no, okay. So, and then there's the other one. That's a bit older. So Leonard Richardson is actually currently in the process of collecting ideas for a second edition. So given how that is so wrong, and just parts of it, and this is a bit older, I very much recommend REST in practice for two reasons. The first is it uses, throughout the book, the REST bugs. It's called the Starbucks ordering flow, how to get a cup of coffee, that you know already because you've hopefully all read the tutorial by then, as examples. So you're familiar with the problem domain. And the other feature it has is, the other thing it uses is it takes you from a level 0 to a level 1 to a level 2 to a level 3 service. So you implement a level 0 service, and then he shows you what's wrong with it and how to improve it, etc. So it's a gradual learning process that shows you with specific examples that you can relate to why you should do it differently. That will be the end. I have no time to take any questions. And yes, thanks.